In this video clip, we will talk about properties of logarithm operations. The first one is log base a to the m times n equals log base a to the m plus log base a to the n. Here we change the operation from multiplication into addition. The second property was log base a to the m divided by n equals log base a to the m minus log base a to the n. In this case, we changed division into subtraction. The third one is log base a to the m to the n equals n times log base a to the capital case M. So here we have changed the exponent operation into the division. We take n down to the front times log base a to the capital case M. Let's see how we are going to prove those properties by using the diagrams right here. This is the diagram. We know if we assume that capital case M is a to the little case m, n is little case a to the little case n, then it goes in two directions. Horizontally, m times n will be a to the little case m times a to the little case n. And then we know we may just add a to the m plus n. Recall that if we have a 2 cubed times 2 to the 5th, that's going to be 2 times 2 times 2 3 times, and then 2 times 2 times 2 times 2 times 2 5 times. In total, we have 2 to the 8th, and which is what? Which is 2 to the 3 plus 5. That's horizontally, we need to add two exponents. Vertically, we have m equals 2 to the m. For example, 8 equals 2 cubed. Then we may rewrite this exponential expression as logarithm is 3 equals log base 2 to the 8. Again, here this m acts like over 3, little case m. And the capital case m like our 8 here. You see here and here. Base is always the base. So then similarly for this one, from here to here. After we get horizontally this expression and vertically this expression, then we may put together. Before we put together, we may rewrite this big expression in logarithm form is to take the exponents down to the front, m plus n, and then equals the base is always the base, log base a to the m times n. If we put this one, if we put this one and this one together, what do we get? Look at this little case m. We may replace this little case m by this one because they are equal. Okay, that's how we got here is log base a to the m. Okay, similarly replace this n by this n, the same little case, and which is log little case a, log base a to the n. So we got the one right here. Look at here and here, we shall get that. On the right hand side, we did not make any change. See that? This one. That's the proof. Okay, for the first 2.7, this property. All right. Similarly, readers can join the proof for 2.8 and 2.9 by clicking here. You can see the diagram, and by clicking here you can see another diagram. Let me show you right here. So you see down here, if you click, right now those are the same as previous one. You see, click that, you will get here is what? Here is the first proof for this property. Okay, if you click here, you'll get a subtraction. And here is division. That's the proof for the second one, 2.8. All right. This one until this one, vertically, this is not changed. Horizontally, it was multiplication. Now it's division and subtraction. And you rewrite this one, you got the following one below it. You combine those two together, you should have this property. Okay, that's how we got the proof for 2.8. For 2.9, so again, the first one is not changed. Vertically, this one is not changed. The only change is here. M to the n is a to the m to the n. You do multiplication between little case m and little case m. You got that. Then you rewrite this one into the logarithm form. Put this one and this one together. You shall have the third property. Enjoying that. So that's your job. Now let's look at a few examples. The first one is the one right here. So this one says that we need to rewrite the following expression just by log base a to the x, log base a to the y, and log base a to the z. The first one is log base a to the x times y squared divided by z. Then you can see here the operation is division. So you may change that to subtraction. Denominator was z, so now it goes here. Numerator was x times y squared. It goes here. Now between x and y squared is multiplication, so that's how you get addition here. Addition here. The second one, log base a to the z is not changed. Now you have exponent. You apply the property right here. Third property, you take exponent down to the front. It means 2 times log base a to the y. And the other 2 is not changed. Okay? Similarly, you can do this one and join this one yourself. You see here, division comes to be subtraction. Okay? And the change in radical z to the 1/2. So you may enjoy this one. Similarly for cube root of y. That's y to the 1/3. Okay? You may enjoy this one in details. Alright. Now, let's move on. One more example right here. If we look at this example, is we want to calculate those two expressions. Here is the multiplication. Then we want to change multiplication into addition. So we will get is log base 3 to the 9 to the 6th plus log base 3 to the 3 to the 5th. Okay. Now, then here there is an exponent 6. You move down to the front. Here there is an exponent 5. Move down to the front. There's 5 times log base 3 times 3. And here is 6 times log base 3 to the 9. So, log base 3 to the 9 is 2. 6, you keep it. 5 to the 5 times log base 3 to the 3. Log base 3 to the 3 is 1. You keep this 5. So the final answer will be 17. Why log base 3 to the 3 is 1? Is because 3 to the first is 3. You may rewrite this one. That's going to be log base 3, which comes to be here, and then put this 3 right here. You have an exponent is 1. Similarly, you may have this one is 2. The reason is what? The reason is 3 squared is 9. Not 6. 3 squared is 3 times 3. Rewrite this one in logarithm form. You have a log. 3 is the base. So you always write 3 here. And then 9 log base 3 to the 9 is 2. That's how we got this one is 2, right here. So 2 times 6, 12, plus 5 is 17. This one is similar. This one. We know 100, you choose cube root. There's going to be the 100 you may write like 10 squared. So that's how we got cube root of 10 squared is 10 to the 2/3. Move the exponent down to the front. You have here is log 10. Remember, log 10 is log base 10 to the 10. Okay, it's like log base 3 to the 3 is 1. Log base 10 to the 10 is also 1. So 2/3 times 1, that's 2/3. All right, I'll see you next time.